This video attempts to explain inverse of a matrix using elementary row and column operations. By an elementary row or column operation, we mean interchanging two rows or columns, multiplying every element of a row or a column by a non-zero real number, and adding to the elements of any row or column the corresponding elements of any other row or column multiplied by a non-zero real number. To find the inverse of a matrix A by elementary row operations, we write A as I into A, where I is the identity matrix. So we pre-multiply by I, and elementary row operations applied to A will apply to I as well. We take an example, find the inverse of this 3 by 3 matrix. We find the inverse using elementary row operations. So we write the matrix as A equal to I into A. Now we try to make this matrix the identity matrix by using elementary row operations, and whatever row operations we apply here will also apply to the right hand side identity matrix. We try to make the lower triangle 0. So we try to do the operation R2 minus 2 times R1. So this becomes 0, minus 2, 5 plus 2, 7, 3, 1, minus 2, 1 and 0. Next we do R2 minus 3 times R3 so that we get 1 here. We try to make the principal diagonal 1. So R2 minus 3 times R3 will give you 7 minus 6, 1. When we do that, we get this matrix. So we have got 1 as the diagonal entry. Now if we do R3 minus 2 times R2, we can get this entry as 0. Doing that, we get the lower triangle as 0. Now if we were to do R1 plus R2, this entry becomes 0 because our next aim would be to get the upper triangle 0. So you get 1, 0, 0 and this becomes 1 minus 2 minus 1, 1 and minus 3. Next we do R1 plus R2 so that we get this entry as 0. So this entry becomes 0 here. So I get 1, 0, 0, 1 minus 2 minus 1, 1 and minus 3. So this becomes the identity matrix I equal to this into A. Post multiply both sides by A inverse. So I A inverse would be this matrix which we have just got into A inverse. So A inverse would be this matrix since A into A inverse is the identity matrix. We now come to a problem where we find the inverse of a matrix using elementary column operations. Consider this 3 by 3 matrix. We write A as A into I. So elementary column operations applied to A will also apply to I. We try to make this upper triangle 0. We first interchange C1 and C2. So if we interchange C1 and C2, we get 1 as the first element of the principal diagonal. So doing that, we get this. Now if we were to do C3 minus 2 times C1, this entry becomes 0. So your matrix becomes 0, 4, 3 minus 4 minus 1, 2, 1 minus 2 minus 1. This becomes 0, minus 2 and 1. Next we do C3 plus C2. So when we do C3 plus C2, we would get, doing C3 plus C2 will give you 1, 0, 0, 2, 1, 0, 1, 3, 2. And this would be a matrix. Now if we, on the right hand side, now if we were to do half times C3, this becomes 0, 0, 1. And this would become half minus 1 and half. We now try to make the lower triangle 0. So if we were to do C2 minus 3 times C3, we would get, this would become, we would get this matrix that is 1, 0, 0, 2, 1, 0, 1, 0, 1. And on the right hand side, this is what we would get. Next we do C1 minus C3. So when we do C1 minus C3, this entry becomes 0. So this is what we get when we do C1 minus C3. Now if we were to do C1 minus 2 times C2, then this entry would become 0. So when we do that, we get 0, 0, 0 here, and this would give you half, you get minus 1, minus half plus 1 is half, You get minus 4. 2 minus 6 is minus 4. This would give you minus 3. And minus half plus 3 is 5 by 2. So we have the identity matrix here. So identity matrix is A into this matrix. Now we pre-multiply both sides by A inverse. So A inverse into I would be A inverse A into this matrix. So A inverse would give you this matrix which we have just found. Going back to the calculations, what we try to do is, in column operations, we first try to make the principal diagonal as 1. Once we make the principal diagonal as 1, we try to get the upper triangle 0. Once the upper triangle becomes 0, we try to make the lower triangle 0. And whatever column operations we apply on the left hand side would apply to the identity matrix on the right hand side.